Hi, welcome back. One more function that appears in computer science a lot, and that we saw when we were counting, is the factorial function. N factorial is n times n minus 1 times n minus 2 times dot 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 times 2 times 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Do be aware that 0 factorial is defined and it's equal to 1, but then 1 factorial is 1, 2 factorial is 2, and so on. Something that often is useful when dealing with factorials is noting that we can write n plus 1 factorial as n plus 1 times n minus 1 times dot 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 times 2 times 1, which is n factorial. In other words, we can write n plus 1 factorial as n plus 1 times n factorial, which can often help simplify some of our calculations. As a function, the factorial function takes in a natural number and outputs a natural number. This factorial function is not injective on all natural numbers, right? We noticed that 0 factorial and 1 factorial are both equal to 1. But if we start looking at the factorial function starting at 1 and going off to positive infinity, that function is injective. It's an increasing function of the inputs, and therefore no two inputs give the same output. At the same time, the factorial function is not surjective because there are elements in the codomain that are not hit. So now let's practice our understanding of the pre-image with a function defined using the factorial function. Let's let g be a function from the natural numbers to the natural numbers, where g of n is the number of zeros at the end of n factorial. Let's first make sure we understand this function. What is g of 10? To figure that out, we need to calculate the number of zeros at the end of 10 factorial. If we write out 10 factorial, we see we get 3,628,800, which has 2 zeros at the end. And so we would write g of 10 is equal to 2. Something to be careful about is when you see an expression like this, maybe your first inclination is to calculate what is g of 0, but that's not what this question is asking. It's asking what is the pre-image of the number 0. And so what is 0 supposed to represent? It's supposed to represent the number of zeros at the end of n factorial. So let's write out some examples. If we have 0 factorial, we get 1. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. What you see here is that we have 5 inputs in the domain where the output of the function g is equal to 0. We know that this is going to have to include the numbers 0, 1, 2, 3, and 4, but can it include any more values? This is where we have to think about what the factorial function does. If n factorial has some number of zeros, then n plus 1 factorial is going to have at least as many zeros. Or in other words, the number of zeros is an increasing function of the inputs. We've found 4 values of n where n factorial has 0 zeros at the end. And there can't be any more because everything after 5 factorial is going to have at least 1 0. And so in fact, the pre-image of 0 under g is equal to the set 0, 1, 2, 3, 4. How about this? What is the pre-image of the number 5? From this observation, we should be writing out various factorials until we find 5 zeros. 23 factorial has 4 zeros at the end. 24 factorial has 4 zeros at the end. And 25 factorial has 6 zeros at the end. What that tells us is that there's no n such that g of n is equal to 5. And so that tells us that the pre-image of 5 is the empty set. All right, and that's it for today. See you next time.